week is our last lecture for our class. And so this topic is based on programming. And let's get into it. So what is programming, especially in regards to WebGIS? So programming is needed to create custom products and to automate manual workflows. Programming, also referred to as coding, is the process of translating a set of ideas into a program, a list of instructions a computer can follow. Also, WebGIS programming can be accomplished at the client side, the web server side, and the database side, depending on your needs. So for our next slide, we're going to look at those options. And workflow automation can automate manual and repetitive tasks or processes. So here we are seeing the main languages for WebGIS development. So here we have the database server side, the web server side, and the client side, including the data exchange formats. So if we're looking at the client side programming creates apps that can run inside web browsers, on our desktops and mobile devices, or on cloud-based integration methods such as webhooks. And we're going to look at webhooks in the next couple of slides. And we can see here, this is the main languages. So Python can be used on the database server side, like we see here, the web server side, and the client side. So now let's talk about webhooks. Webhook became an increasingly popular method for automation. A webhook is a mechanism that allows an application to provide other applications with event-driven information. It is more efficient than polling, and we can compare polling and webhooks here. So for polling, there are a lot of options given. For example, is my data ready? And the software says no. Is my data ready? No. Is my data ready? Here's your data. Whereas with webhooks, we can see with this cloud-based program here, tell me when my data is ready, here's your data. So again, it's more efficient than polling. It allows users to create custom event-driven workflows that can be integrated across multiple systems, and it creates new and more efficient opportunities for automation, like we see in this example. So these are the key terms for webhook. We have trigger events, and a trigger event means when the event that triggers a webhook. So for example, it states here, users, groups, items, and features in layers are added, updated, and deleted. So again, we know as a user for ArcGIS Online, we can either add a new layer or edit our layer. So someone in the organization will get notified eventually with our action that we see here. But the process to get to our actions, when webhook notifies you, you have to go through the webhook configuration. So again, ArcGIS Online and ArcGIS Enterprise uses webhooks. A payload means that the trigger event data is sent to the webhook. So it notifies the webhook what is going on here. Did a user add data? And then our integrators are Microsoft Power Automate or Zapier. And finally, our actions. So action means something that the webhook does or further invokes. So you may get a notification through email, SMS messages that about the trigger event of what occurred. So again, GIS Online and ArcGIS Enterprise support comprehensive trigger events, which include when items are deleted, added, updated, or shared, and so on. So we could see here, this is an example of a webhook. This is an email notification when a survey response is received. So the trigger event here is when a survey response is submitted. And then our action step, if it was submitted, it's to send an email. So this example is going through each of these steps that we just went over. Another example of using webhooks would be if you want to receive an SMS message notification when a new service request is submitted using Survey123, and we have used Survey123 for our previous lab assignments. Next, I want to talk about JavaScript. So JavaScript is the most widely used web programming languages in the world today, and almost all web pages include some JavaScript code, and it's a bridge between web browsers and web servers. JavaScript interacts with servers to use the server's capabilities, and it works with web browsers to make web pages dynamic and interactive. And there is no plugin needed for JavaScript, and it runs inside web browsers, and it supports mobile platform well with HTML5 and responsive web design. And JavaScript is relatively easy. You can write JavaScript using any clear text editor and load and run the source code in a web browser. And these are the major development frameworks for JavaScript. Right here, for example, Dojo. So JavaScript works in conjunction with HTML and CSS for building web apps. And to develop web apps using JavaScript, you must know at least the basics of HTML and CSS. So you need to know all three. HTML is a markup language used to package your content. CSS is a formatting language used to style content. And JavaScript creates dynamic and interactive features for your web pages. So HTML, JavaScript, and CSS work together in web development. So next, let's talk about JSON. Also stands for JavaScript Object Notation. And webhooks rely heavily on JSON for storing and exchanging data. It's a lightweight and easy to understand format for storing and exchanging data. And the syntax to use JSON, you have here an example, the syntax. So data is in field underscore name, and it gives you the value pairs, and data is separated by commas like we see here, name John, comma, hobby basketball, comma, and curly braces hold objects, whereas square brackets hold arrays. So for this example, this JSON code describes an array of 2 students, and we could see the 2 students' names here. Let me circle it with my drawing. So we have John and Lisa. And each of these 2 students is represented with a name field and a name value. So again, this is our name field, and John is our name value. And we also have a hobby field and a hobby value. And we have an address field and an address value. So this is the syntax when you use JSON. Next, I want to talk about Python. Python is an open source general purpose programming language used as a scripting language in ArcGIS geoprocessing. So this Python was created in the late 1980s by Rossum, and it was introduced in 1991. ArcPy is a Python site package that provides a useful and productive way to perform geographic data analysis, data conversion, data management, and map automation with Python. So Python provides access to geoprocessing tools as well as additional functions. And when we're talking about geoprocessing tools, you can think of buffer, overlay, and so on. And also, it provides access to classes and modules that allow you to create simple or complex workflows quickly and easily. So the advantages of Python, while it's easy to learn and it's excellent for beginners, it's highly scalable, suitable for large projects or scripts, and it's embeddable, which means it's making ArcGIS scriptable, and it has a large user community. So this example here is running a tool using Python, and this example shows how to execute the buffer tool. So we could see here we have buffer analysis, and it's using ArcPy, and they are creating a street buffer for 500 meters. So if you scroll the arrow more, you would see it being more specific with 500 meters. Next, I want to talk about Model Builder, and we are familiar with Model Builder, but the reason it's important for this topic is because Model Builder is a visual programming language for building geoprocessing workflows. And you can build a model by adding and connecting data and tools like we see here. We have two data sets. We have vegetation, a vegetation layer, and a major roads layer. And we have our tools, which are select by attribute and buffer. So using Model Builder, you graphically chain together a sequence of tools from the toolbox. The editor is fairly easy to learn, and the finished models serve a secondary purpose as diagrams for documentation and communication to others in your organization. And Model Builder is a simpler alternative to Python scripting and ArcPy. So you can make your model into a geoprocessing tool that can be shared, or it can be used in Python scripting and other models. And for this example here, this geoprocessing model is used by a conservation organization to identify potential habitats for an indigenous bird species based on vegetation type, distance from major roads, as well as climate zone, slope, and elevation. And then finally, we have our final layer. And this final layer identifies the areas that meet all criteria. And also with Model Builder, behind the scenes, Model Builder creates Python codes that you can view. So if we watch this short, fast video, oh, I'm on draw mode. Let's take it off. Okay, perfect. So to look at the Python code, you would have to view the script using a Python editor like IDLE, like what this person is opening up right here. And this allows you to view the Python code. And it's using ArcPy. Okay, so that's it for our lecture this week. Again, for this module, you will not be doing a quiz, you would just be doing discussions. And please review the final review guide, and our final exam for this course is next week on Friday, June 7th, and you have until midnight. So if you have any questions, please visit me during my office hours, or email me or send me a message on when you can meet. Thank you for watching.